So once we got the price elasticity under our belts, we can do an elasticity for anything. And that's what we're going to see in this chapter a little bit, is that you can create an elasticity of anything. So income elasticity, how much more do people buy if their income goes up, right? Income goes up 10%, how much more do they buy? Or do they buy less, possibly, if it's an inferior good? Elasticity of variable x with respect to y is the percentage change in x over the percentage change in y. So we can do it for anything. All right. So how about births?
So when a man and a woman love each other?
Okay, good start, good start. Yes, let's get to the good part. They lay down in bed. Okay, no. So we're actually not talking about human births here. We are talking about firm births, the birth of a business, so a startup. So part of this spatial economics is like how many businesses have started up, how many businesses have gone away in Ottawa, right? So we have new businesses. There's a new restaurant on 2nd Street, I think, called Roasted Cafe, I think it is. Yeah, I was surprised. I just drove past it. I kind of did a real soft opening, and then I saw the chamber put out something. So we have new companies start, other companies close down, so there's kind of that churning process. And so we can start to think about productivity and birth. So there's our productivity, output per unit of input, and the number of new firms. And we can start calculating some elasticities, like that one. So the elasticity of output per worker with industry output. How do we interpret elasticity in general? So if the elasticity of beer turned out to be 2.37, negative, of course, but absolute value would be positive 2.37. But how do we interpret an elasticity? Anybody remember that? It's kind of a nifty little trick. No, I thought you were almost on the right thing, but there's a little trick to interpreting it. It flows right from this formula. What can I do with any number to express it as a fraction? Put it over 1. So that's our little trick, is if the elasticity of demand is 2.37, I can put that sucker over 1, and now I can interpret the elasticity of demand putting this sucker with this sucker, and this sucker with this sucker. So a 1% increase in price leads to a 2.37% decrease in quantity. So that's a really cool thing. We can do that with any of these elasticities. So on this particular elasticity, we got output per worker and industry output. We can put it over 10 or we can put it over 1. So with this one, if we instead, with this example I just used, I could say a 10% increase in price and then shift this decimal place over here. So a 10% increase in price leads to a 23.7% decrease in quantity. So you can interpret it either way. Sometimes it might be easier to think about increments of 10%, or other times maybe 1% makes it easier. So where we've got output per worker and industry output, a 1% increase in industry output, the denominator, a 10% increase in industry output leads to a 1.1% increase in output per worker. Okay? Questions on that? Just shaking a few cobwebs out.
Didn't you just say if you like that on the other side of the thing, 1% denominator is a key piece of the numerator?
Over here it was because the elasticity is negative. Here the sign is positive. So it's only with the price elasticity that we sometimes like do the absolute value thing. So otherwise, if we're just looking at two variables, if that's positive, that means an increase leads to an increase. Or if it was negative, an increase leads to a decrease. Then it would be moving opposite directions. Okay, anything Anything else there? How about that one then? Why don't you guys write this down in your notes? So this was estimated by an economist, Carlton, on elasticity births and industry output. Industry output and births. So they were studying a industry level type of thing here. And you can use 1% or 10%, I don't really care. You should write out a full sentence. This is what you do for your boss if they said, oh, what does this mean? I never had an econ class. What is elasticity of 0.43? What does that mean? Now you got to write out a sentence. What does that mean?
Is burst being our quantity?
So the way this textbook does it, so the first thing listed is the numerator. So that's up top, that's on the bottom. And I will randomly select one of you and I will read your answer aloud. Make sure you print nice for me to read. And you've got 15 seconds left. 12, 11, 8, 7, 3, 2, 1. JC, give me a number between 8 and 15. 8. 1, 2, 3, 4, 5, 6, 7, 8. That's fun.
Oh.
Okay, what's your,
Think yourself.
I don't think I've had that happen because I usually have it without, so that was kind of fun. All right, a 10% increase in industry output will make a 4.3% increase in births. What do you think? Is that what you got? Okay. So, and I would just use the word lead to instead of make. Yeah. So it's not like a production function, but it is an estimate. So, good. All right. So, 10% increase in industry output leads to a 4.3% increase in firm births. All right. So here we go. So we got a supply curve, and we can think about why is it upward sloping? Why does it need to be upward sloping? So as we start to get more and more workers into a city, so one thing that's a little bit different here is we are thinking about the urban labor supply so that we're getting more and more people into the city. So we got those issues of congestion and other things. Why does it need to be upward sloping? What's going on here in terms of the supply of labor?
With more workers, you have a higher supply. So it's kind of
so we're talking about people coming to work for us, though. They are the supply. So what I'm wondering is what keeps a person from coming into the city? As we get more and more workers into the city, what this is saying is that the 221st worker isn't going to come here unless they get more pay.
Yeah.
That's what the upward slope would indicate. And why? Yeah, Nate?
Well, because like as the city grows, like transportation costs get higher and like demanding for housing and stuff.
Okay, so cost of living starts to go up, right? And congestion and commuting costs and land rents and all of that stuff. So they really need a higher amount of pay to be able to get to what they need to be. Okay, so we get amenities, disamenities. What's a disamenity? Opposite of amenity. Good, good.
good explanation.
Disamenity. Give me an example of a disamenity. Higher gas prices. I wouldn't really think of gas prices as being an amenity. That if they're lower, it's an amenity. If it's higher, but it's not too far off. Yeah, those,
So this means like something that would decrease like the attractiveness of going to a city.
yeah,
So maybe like congestion.
congestion, yeah,
Pollution.
pollution. So crime, yeah. So all the things that aren't going to make it attractive, right? And then taxes might need to be higher or lower depending on what's going on. So we got those sorts of issues that we're thinking about. For the labor demand curve, it is downward sloping. And so again, these are the businesses. So we got a substitution effect, an increase in the wage. Firms substitute other inputs for relatively expensive labor. So if we have to, if minimum wage legislation is going on and we're going to have a face of raise and pay, I'm going to start to look for substitutes, right? But as labor gets cheaper, I shouldn't really be pointing to that curve. Labor curve, not the chicken wing curve over there, the beer curve. So as labor becomes less expensive, if we're measuring wage, then we want more labor. Because I can start to get rid of some machines or get rid of something else with my production process and start hiring more people. So that's the substitution effect. And then the output effect, we can start to look at the production costs. So a decrease in output decreases the quantity of labor demanded. So what's the output thing? Where's that coming from? Increased production costs, increase in the wage, output effect, the productivity. So yeah, it's getting more towards that productivity part. So when I look at the marginal revenue times the marginal product, how much is that going to affect if I have something changing where something affects the output? If people's productivity falls, then I can't pay them as much, right? So same type of thing there, those two effects giving us our negative slope. How about a shift? What causes an increase in labor demand? Make that sucker move to the right. An increase in the demand for export goods.
Oh,
This is good. So let me, what's an export, I guess? Let's start there. Some of you are in international and or macro. What is an export? We're shipping out. Now, normally in macro or global stuff, we're shipping out of where on an export? Out of the country, right? But now in this class, we're going to think about it shipping out of our city. So it's going to be kind of a similar thing, but there might be a difference between goods that we domestically produce and consume, like haircuts. So in Ottawa, we have haircut producers and haircut consumers. How many people drive from Lawrence to get their haircut here?
Probably no one.
Probably no one.
Drive from
Close to no one, right? JC's saying he does. So maybe there's a few, but there's a lot more domestic consumption as opposed to foreigners coming in, right? Whereas there's a plant up on the north side that makes specialized containers that are used. They make the truck that pulls shipping containers around, and that, how many Ottawa people buy those things? Probably close to zero. It's actually a very specialized truck that's used in ports and in other places that ship them. It's funny that I even brought that one up because I went to that Walmart luncheon yesterday, and one of those trucks was being used at Walmart DC. They were moving stuff into the yard. So maybe there's a buyer or two domestically, but for the most part, those are all going out. So what else would cause, so if there's an increase in demand for our product, then I need more people to make the product. That's all number one is. What else influences the labor demand curve that would cause it to shift?
Labor productivity.
Labor productivity. So what would make us more productive? What could workers use that allows them to make more output? Number of units of output over the number of units of input. That's productivity, right? So what machines? So we give somebody a tool or machine and they can be much more productive perhaps at their job.
What about like an increase in the total revenue?
Total revenue, so our sales go up, our total, well, so the demand for our inputs is going to increase that, right? So we're going to, that's the one that's kind of trickling in from that input. So locally, we might have taxes that could help us if the city decides to decrease taxes, or the state of Kansas, if we talk about that or something, then that could cause us to need, we're able to make more stuff, and therefore I need more people to make more stuff. All right, land use policies. We're going to have a whole chapter on that coming up, but land use policies. Anybody got a stab at that? Yeah, Eddie?
Can't build a factory downtown.
Yeah, you can't build a factory downtown. So what are the allowed uses? So it's possible that if the city changes a land use that works to your benefit, then you might expand your company. If you expand your company, you need more workers, right? So a lot of these things can kind of trickle into your demand for goods. All right, any questions on that? All right, so with the haircut versus the export good, what's going to be more beneficial for our city in a sense, or in one way more beneficial? Which one's going to have some additional benefits? So how does export employment, more employment like the North thing that builds the things as opposed to just more haircut people, how does export employment multiply employment? We have a large factory or something come in, yeah.
So the thing of export product, it makes me think, so I'm obviously outside Lawrence, and like they want to bring in a Tyson factory.
Yeah.
And like our entire town was against, like we were like, we were.
Oh yeah, I remember that.
Yeah, it was so bad.
Oh, sorry, I
And
didn't
so,
say thank you.
in my mind, it could be good and bad. Like I think it's going to bring a lot of jobs to town.
Yeah.
But the reason everybody is because it's going to stink real bad, and people didn't want necessarily some of the people.
Yeah.
Going to
Yeah, that's a good example. So when you bring in a big factory like Tyson plant, most of the people aren't the ones, the primary consumers of it, right? So it's definitely an export good. And so how does it multiply? So if Tonganoxie would have maybe
They talk about like,
decided it was better to go the other way and they wanted the plant to come to town, what would happen in Tonganoxie? How many employees do you remember? How many?
I thought about maybe I want to say like 1,000 employees.
Woo!
It was gonna be huge.
Okay, so 1,000 employees come to town, each one making on average, usually they have stats, I don't know if you know them or not, but I'll make up a number if I need to. So we got 1,000 employees, and let's just say they're making $30,000 a year, right? So $30,000 a year. So how much money is that in terms of income? It is a lot, isn't it? This is where people don't know, oh, that's stinky, I don't want stinky chicken. 30 million, we got $30 million coming into our town from the chicken plant. And what do those people need to do every month or so? Get a haircut.
Let's say because they're support local business.
So now those 1,000 people need a haircut. And so is the number of haircut salons going to go up or down? Up. More pizza places, more other things, right? So that's the multiplier effect. We bring in outside firms that have this export concept going where we're really bringing in kind of new money. It's not staying within the community, and that can have a big impact. Ottawa, since I'm serving on this Franklin County Development Commission, we've got the big piece of land out on the south side of 35 that we're hoping something like the Tyson plant or some other business is going to come in.
You guys bought that land?
Huh?
You guys got that land? I had an idea for it.
Okay. Well, you can talk to me after class. Okay. So, well, we are going to look at that piece of land actually as part of this class later when we get more into the land development, because But now you're in the thing of, should the city get involved in buying land or helping developers get land? Should the city put in infrastructure in the land that makes it more appealing? So that we'll talk about that later. So that is the concept of the multiplier. So those local workers were going to go spend money, and now we're going to have more employment. It's going to build. So economists have estimated this multiplier by industry. And so it's funny that you bring up Tyson Foods, Dakota, because it's right at the top of the list here. Frozen food manufacturing, which is probably what Tyson was, making chicken nuggets or something, right? A 2.4 multiplier. 2.4 multiplier in terms of number of jobs. And then some other industries, you know, here's optical instrument and lens manufacturing, whatever that industry means, right? 1.46. So why do they vary by industry? What would be the, if we think about an industry's production, it's like, oh, bring this industry or that industry. What would be the determining factor that would cause one to have a bigger bang than another one? Amount of jobs. What else about the jobs? How much they pay, yeah. So how much money they pay, that's going to have a contributing factor. So there'll be a balancing of a number of different things. Okay, so there's going to be some spectrum within the company of how much is local sales and how much is export. So the relationship, bigger fraction of export sales leads to a bigger or smaller multiplier. Bigger fraction, I heard smaller. So the bigger the fraction of export sales, like the company up north in Ottawa, like the Tyson food plant, so is that going to lead to a bigger multiplier or a smaller multiplier? Bigger. Survey says bigger. It's like a game show around here. Okay. So metro average. So across the whole, this is Portland, Oregon here. Across the whole metropolitan area, those numbers average out to be 2.13. So in terms of cities wanting to, you know, find new companies to come in, that's one reason. You can have, even if you just bring one company in and they only have 57 jobs, if it happens to be a heavy export-related business, then that's going to have a bigger multiplier. So those 57 jobs are going to lead to potentially even more. Oops, I wanted you guys to do that. Okay, too bad. I guess I'm giving you the answers. So 2.13, a 1 job increase in export employment. So of the 1,000 Tyson jobs, a 1 job increase leads to total employment of haircuts and other places. Total employment goes up to 2.13. So we're bringing in 1 job, but it's adding another 1.13 jobs. Right? So total employment, so that 2 is not bring in 1 and you get 2 for a grand total of 3. That's not what it's saying. Bring in 1 and you're going to add 1.13 jobs.
And that's talking like in the town.
In the town, yep, of Tonganoxie. So we would have had 1,000, but now if that number was true, you would have had 2,000 jobs with the extra hair salons and pizza places and other things that would have happened. Okay? All right, questions on that? So what does that mean for the demand curve? That multiplier effect, once it kind of plays its role, is going to lead to a higher demand for labor in Tonganoxie, right? So with the multiplier, we have a new job come to town, but not only does the chicken place not only does Tyson's need people, but now we need more hair salons and pizza places too. So that's kind of this, you can imagine that curve kind of shifting out once we have the total effect with the multiplier. Okay. Oh, there's my fun stuff again too. Direct effect, multiply effect. Yeah.
So wouldn't that like raise the wage though? Because we talked about how like that would like expand the city and raise the cost of living.
All right, good point. Why is the wage not going up in this picture?
It's lower.
Nope. Supply stayed the same. I don't know that.
Well,
Because what's this picture missing?
this we don't have the supply.
We don't have a supply. So now we do.
In each case, the supply is shifted with the dimension, or it is just a,
It could be that, or pretty flat.
Yeah.
Then there wouldn't be much movement. So depending on if it's flatter or steeper, what's the word? The elasticity, right? So as it becomes steeper, it's more inelastic or less elastic. Flatter is more elastic. Okay, good. Anything else on that picture? All right, so projecting total changes. So the multiplier business, let me go back to that picture here. We were kind of playing on that 2.13. So a change of 1,000 jobs, of 10 jobs, normalized from 100 to 10, led to a little bit more than that, to 121, right? So that is, though, assuming the wage holds constant. So that multiplier effect assumes a constant wage, which is an issue, because what we're really going to observe in the real world is the equilibrium. There is going to be a supply curve, like you guys pointed out. So it's not as easy to just look at some multiplier number and say that, boom, 2.1 or 1,000 jobs, Togonox is going to lead to 2,100. So, this is the other criticism with this multiplier approach, is that we kind of feel like, oh, our city is dependent on an outsider coming in, and then we might be tempted into doing some other things that might not be the right way to look at it. And also on the jobs, as we talked, is this a $30,000 a year job, or is this a $70,000 a year job? That would make a big difference as well. So the multiplier has its shortcomings when we're just looking at those stats. Okay, so let's see, we kind of already did this one, but I think I wanted to do this. So with the supply curve, we've got changes going on with the labor force in relationship to other variables. So let's take this one here, the elasticity of the wage, basically the wage per person on average, to the labor force. So as the labor force grows, what is that going to do? Claudio, what are you so interested in? Are you on our task here, or why don't you turn your screen for me for a second?
I got different thing.
So you're gonna lose a point today. Okay. Boy, you need all the points you can get. So why don't you close out of all of that? Make sure you're on task here. So, somebody want to give me an interpretation? Interpret that point 2.
measure labor force goes up, say like by what JC used earlier, 10%.
Okay.
Your wage is going to go up by 2%.
2%. Yep. So it's the same process. That's why it's kind of good to do. So this goes up. Oops, I thought I had a little thing that did the interpretation. So yes, put that over 10, slide the decimal place over. A 10% change in the labor force leads to a 2% change in the wage. And then same thing here. A 10% change in the wage. And notice that we just flipped them around. So sometimes we could have one on the bottom or the other if we're thinking about the wage. Usually we try to do it so that what's driving what is a change in the wage creating the labor force to increase, or vice versa. And there could be competing reasons of why it's changing. So you might do it a couple different ways. Okay, so why does that sucker move around? What causes an increase in the labor supply? Shift to the right. So amenities might be nice playgrounds and nice parks and biking trails and fishing ponds and whatever. So what else? Free pool. So improvement in amenities. What other things outside of that? What else would help? A decrease in crime. So having less disamenities would be nice. Residential taxes. So we kind of have the TIBO, which we'll get into later. The TIBO theorem that people will vote with their feet and kind of move around. And then public services, so again, maybe a swimming pool, as you mentioned, or something else. So that can be attractions to, for our city. What do we have going on in auto? Yeah, sorry,
I was
DC.
gonna say, because then the farmers, the other people that sit on the wait list, right?
Yes, perhaps, because less of a chance of getting, and just less chance of getting beat up. So healthcare costs might be less than other things. Okay, so there's our equilibrium together, right? So we have the supply and demand. So this is the fully shifted out demand. If so Tyson comes to Tonganoxie and then haircut places, so kind of long term would put up some upward pressure on those wages. So why does slope matter?
So that the supply.
The slope of both, but the supply is what I was thinking of. So what's the?
How much the change is.
Okay, so the change is either going to be big or small, right? And so if it's more elastic or inelastic, you'll get a bigger bump in pay. Yeah, more inelastic or less elastic, right? The steeper it gets, the bigger the bump in pay will be. So as the labor supply curve starts to get steeper, then we have a bigger effect. All right, so how do we get that? That's the multiplier we really care about. So notice we're going from 100 not to 121 with the multiplier, but from here to here. So now, as the thing for food for thought for your weekend here, we have a nice little formula. You guys in intermediate did a little bit of this before, but the percentage change in the price, the equilibrium wage, is equal to the percentage change in the demand divided by the elasticity of demand plus the elasticity of supply. So write that formula down. That'll definitely be on your homework problems. What's the equilibrium wage? So, so if we, just to kind of play around with that thing, percentage change in the equilibrium wage, and then it's got equals that sum. So the sum of the elasticities gets you to that point. I was going to do something, but I decided it's not what to do. I was going to say proof not required, and then I immediately want to get geeky on you and show where that comes from, but that's not it. So, if demand changed by 21%, which was our 100 to 121 with the multiplier, right? So we could estimate through our studies that the multiplier was 2.13 or something. So we were able to get that we're currently here, and that would lead to a 121, so a 21% change in demand. If we've estimated elasticities at 2 and 5, then what is our wage increase? 21 divided by 7. 3%. And it climbs from 100 to 103.
Well, it's never going to be most likely 100 to 103. Right. That's, you can just look at that.
What the wage, you mean just that?
Because you can look at that and say, okay, the wage difference is 2% increase. Just by just from that numbers. So it's not, I hope it's not.
Yes, right. Well, whatever it would be, if it was $10 an hour or 20, is that what you're getting at, the size of it?
Basically just how easy that one, you can just look at that one, the wage change.
Okay, yeah. But this is what you might be asked to calculate in a problem, like a 3% change. Or it'll say, currently the wages are $20 an hour, so a 3% change would be 60 cents.
Is
Yeah.
elasticity of labor demand EG?
Yeah, yes, over here.
Yeah. The
Yes.
wage elasticity of supply.
Yeah, it's the demand for labor elasticity. All right. Yep, I'll keep it up there. See you on Monday.